Hi, I'm Joanna Gustafson,
I'm Brian Davis.
And I'm Tim Williams.
and this is our light sensor project. And our first objective was to design an analog sensor that is compatible with a computer.
Our second objective was to help others in the class complete the project and get their sensor working properly.
And thirdly, we had to calibrate the sensor and add an LED that would turn on at a set value.
So why we use the Arduino? One, because it's very easy to use. Two, because there's a ton of information online between the Arduino websites and other websites that people have posted. There's lots of online software and places where we even got our code from, and it also connects right to the USB.
So here is the circuit we used for our final design. You can see here, coming out of a 5-volt voltage source, this red wire carries the voltage into a voltage divider with the photocell, and then coming out of that voltage divider, this white wire brings the signal from the photocell into pin A3. Then on the digital side of the board, we have the red wire is the digital output from pin 13, and that's going into the LED, and then the black wire is just a grounding it to the Arduino board.
The first code that we had to write for this project was to get the sensor to communicate with the computer. Now, in order to do this, you first have to declare integers at the beginning of the code. In this case, we are using integers photocell pin and photocell reading. And in order to print out a value in the code, you need to have a line such as the photocell reading equals analog read, and then with the integer analog read, you then have a print statement printing out that integer. Now, depending upon the value that the photocell has at the current light, it'll either display as dark, dim, light, bright, or very bright. And if the photocell sensor is reading less than 30, it'll display dark, but if it is reading more than 30 and less than 150, it'll display dim. An important part of this program is the delay function seen at the bottom. Depending upon the value written after the delay will determine how fast the code refreshes. To run the code, you first have to verify or compile the program using the button in the top left. Now, when it is done compiling, it'll say done compiling in the bottom left. However, if there were errors in the code, it would display in the prompt below where it says binary text. Now, before uploading to the chip, you need to make sure that the correct serial port is connected in order for it to upload correctly. In this case, we are using COM port 7. Once the correct serial port is selected, you may then upload to the chip. Again, it'll say done uploading when it is complete. And then you can view the serial monitor using the button in the top right. Now, what this does is display what the code is told to display from the sensor values. Now, in the light that is presently in, it reads a value of around 240. As I cover the light with my hand, the value will decrease and display the term dark. Now, if I let go, it'll return to around 300. And then as I shine light on it, it'll get brighter around 400 and display bright. The second code we had to use for this project was to calibrate the sensor. Since we're using a light-dependent resistor, and we are reading a value of volts, we converted that value to read lux. This is done by the equation found at the bottom. After doing research online and collaborating with Matt, Chris, and Adwait, we established that this equation would work correctly in our circuit. Now, as described in the previous code explanation, again, we had to declare the integers above and then use a print statement in order to display the information. Now again, you have to verify the code and then upload to the chip and view in the serial monitor. Now, unlike the first code where it refreshed every few seconds or milliseconds, This one only refreshes when the sensor senses a change in the light around it. Now as I hold my hand over the sensor, you can see that the lux value drops as well as it refresh. And as I take my hand off, it returns to the value of about 280 as it was initially. Again, and as I shine the light onto the sensor, it increases, and then as I shut it off, it decreases to about 300 lux. The third and final code for this project was to incorporate an LED in the code and in the circuit. Now as you can see from the code previously shown, this is very similar. However, the only main difference are these few lines displaying the LED. Now, in order to turn on and off the LED, we have to have a digital write function. Now, the 13 in the digital write parentheses signifies that it's pin 13, which is a digital output. And in this loop, it says if the lux is less than 300, it'll display a low signal to digital pin 13. Now, if the lux exceeds 300, it'll display a high signal to digital pin 13. Again, I will verify this and upload it to the chip and view it in the serial monitor. Now, as you can see from the previous demonstration, the code itself has not changed, but rather we have just incorporated an LED.
So here's a demonstration of our sensor working. You can see when we shine a light onto the sensor, the LED turns on. We declared in our code for the LED to turn on when the sensor reads over 300 lux.
During the completion of our project, we ran into several problems, one of which was code writing. Our skills in code writing were limited, so we were forced to do outside research online. For our code, we had to combine several different codes online to create a working code that would work with our sensor.
Another issue we ran into was we started by using the MSP430 as our microcontroller, and we soon discovered that we were unable to use it due to its inability to use real-time, and we wanted to have a real-time output of our data that we collect through our light sensor. Also, with the MSP430, we were unable to get a code that would successfully compile the data and collect the data from our light sensor.
Thirdly, a problem that we encountered was calibrating the sensor. We had trouble trying to find an equation that would work with the data that was collecting with the sensor and to output that in a unit of lux to read the light.
And the last problem we ran into was trying to produce a real-time graph into Excel. We could get the data to go into Excel while it was running, but we couldn't get actual graph to produce while it was running. So in order to help everyone else in our class, we created a blog called the Wikispace, and it's basically there to help everyone else share information with each other. You can post like your PowerPoints, Word documents, any external links that you want to post on the site. We put up pictures, our code, videos of our working sensor, and there's also a section where you can create discussion topics, and it's basically like a chat back and forth where you can answer each other's questions, and the site's in general just there for everyone's use to help everyone else complete their project. So this is our Wikispace. The URL can be found up here, and this will take you to the home page. Once you get to the home page, it basically gives a brief discussion about what our page is about and tells you that basically this website is to help everyone in our class complete their project. If you go over to the left here, you can see everyone has posted their projects who has joined the Wikispace, and this one right here is our project. Here you see that we posted our objectives, list of materials, a picture of the schematic, description of the photocell, and then a picture of the photocell. Here's an example picture of an Arduino with a brief description underneath. Here's our code. Down here is a picture of the output that displays on your computer screen when we run our code. This is the graph we were able to produce from the data that we were able to import into Excel. And then we also posted a video of our circuit running. And then we also posted pictures of our actual circuit. And if you go back up to the top, you can go back to the home page. And then you see this discussion page right here. And basically here is an area for you to make a post and ask a question to anyone in the class who's on the wiki space. Here's an example right here that Matt Bedard did. He posted a question, and as you can see, Zach Barron tried to respond to Matt's question and help him out with his problem. And then if you go back over to the left side, we posted a page with external links, and each of these links helped us in completing our project, and we thought they might be useful for others. And next to each link is a description of what you can find on each page. And then, yeah, basically as you can see over here, everybody else has posted their pages. This is an example of another group's page. And so we basically just created this for everyone in the class to use, to help each other out and just share information as easily as possible. And to join the wiki, just click this link over here and you can start posting your information on the wiki space.